Danger 4 Research Laboratories Incorporated, and we appear to continue to have science going on this bench. So,
are you ready for science?
I think they're ready for science.
This is a linear induction motor common to roller coasters. So what we're going to be doing is pushing a magnetic flux wave through a series of coils, like a coil gun, against the floor. So imagine this flipped 180 degrees around. There's a steel floor and we're scooching along on it. This is our steel floor. This is the surface of the track. It's 3/8 of an inch thick, very similar to what we'll be running. It's kind of a really bad skateboard. So right now there are 4 bearings to constrain it, and then 2 bearings to constrain it laterally. This lives on top of the linear induction motor. You can see there's a gap. It's a tiny gap. It's about an inch, between 1/8 of an inch and 1/4 of an inch. The cart can move on this track a little bit. Ideally, we're just trying to measure force here. We're just trying to get some science done. This is a strain gauge. As you pull, it displays force, and it does that in a live fashion. There are 2 bolts. As this cart pulls, it pulls against the strain gauge and gives us a force value. We're studying, with all of this magic over here, what frequencies work best with the steel floor on the BattleBot Arena. So without further ado, we'll do some science.
Name of science. Weird science.
Okay, here's our linear induction motor. Safety goggles, Frank. Safety goggles. This is our linear induction motor. We're going to cover it with a sheet of plastic just to demonstrate the magnetic field effect. This is a plate of aluminum. The floor is not made of aluminum, but we're just showing as an example of what eddy current forces are. So right now we're off. It does nothing. There is no force, there's no magic underneath here besides electromagnetic forces. We're going to power up, we're going to increase our bus voltage a bit, and we're going to demonstrate the effect. So right now, I'm not holding it. You can kind of see underneath it, there's nothing in contact. And here's the force. It does quite a bit. That's just an aluminum plate and magnetic fields coupling in eddy currents. Electromagnetic forces, go! This is our steel floor. This is the surface of the track. It's 3/8 of an inch thick. Force gauge is set for continuous pounds. We're running a V-bus. Bring it up. And frequency 32.1 hertz. And I want to say it's like 9.2. 32.2 hertz. Bus voltage is on, and go. Nice.
Early. Let's see if Overhaul can get something going here. Oh! Overhaul getting pushed right into the rail. Up on its hind wheel. Paul Ventimiglia showing his talent as a driver. Overhaul trying to fight back, trying to overpower and fight for us and get off that wall.